So for all of you who are slowly nodding off because of lack of caffeine, there is a UC Berkeley is going to give you a free tour of the quad if you can spot the changes between what's published and what he presents. Right?
Yeah, sure.
Okay. Contact Chris for that.
All right. Actually, I was going to say thank you for all coming out here for the official UC Berkeley version of the Nanog.
This is a microphone.
I was going to say thank you for the for coming out for the UC Berkeley version of Nanog. Okay, I'd like to start off by going over some of the introducing you to some of the things that we're going to talk about. First, we'll go over the wireless coverage at UC Berkeley in terms of number of access points, number of users, buildings covered, etc. At Berkeley, we limit our wireless network to campus affiliates, that is students, faculty, staff, and researchers. So I'm going to go into a little bit of the authentication system and the logical components of our wireless network topology. Then we'll drill down into a little bit of the network detail, and look at the connectivity between some of those components, and as it was at the time of the release of the Welchia worm. So we'll talk about the Welchia worm, its propagation, and some of the effects that we felt at Berkeley. And then we'll look at some of our reactions to that, both in the immediate sense of regaining control of our network, as well as identifying, alerting, and cleaning some of the hosts that were victim to this. Then we'll finally take a look back through the dust as it was settling and take a look at some of our afterthoughts. Okay, I'm not sure if the color comes out here, but the green are the buildings where we have wireless coverage. Now at UC Berkeley, the campus mascot is the golden bear. So we have telebears, we have bear mail, bear everything. Air bears is what we call our wireless product. So if you look at the airbears.berkeley.edu site, you can mouse over some of these green buildings, and it'll give you a little more detail about the buildings, the intended coverage, things like that. Now, what this map doesn't show are actually a couple of off-site buildings that do not that don't appear on this map that do have wireless coverage, like my office, for instance. But I guess that's not important enough to be on the map. So we have currently we have 217 access points, and those feed up into 14 access managers, which are in turn served by a single control server. In the last month alone, we had a little over 3,900 unique authenticated users, which is an almost 80% increase from May of 2003. And you can speculate as to the reason for the incredible increase there. One reason you can think is this is the spring semester, everyone went home and they got laptops and PDAs for Christmas, and now they all want to use them. Another reason is that we have an incredible expansion of wireless on campus, partly in conjunction with a grant that one of our professors got. He's studying the effects of wireless and education. So we got a huge donation of wireless access points, and now we're scurrying to put them all in, and I believe we're going to get a whole bunch more this year. So next year you look at this map and it'll be almost all green. So I guess my work is cut out for me as well. All right, as I mentioned, we have an authenticated system at Berkeley. So a client will go up, it'll send its traffic up into the access point, and that feeds up into the access manager. The access manager looks at each packet, and based on its MAC address determines whether or not this particular client is authenticated. If it has been, then it will go and pass the traffic. If not, then the captive portal there will take that, send it up into the control server, and the control server sends back a secure login page, and the student puts in his password and his or her password and login ID, and then once that's authenticated, then their traffic will pass. Now, if you think about this, we have 217 access points. We have thousands of users and 14 access managers, and these are all going back to the same control server, which is feeding all of these pages. Well, that's not a very good use of the service. So that actually becomes a bottleneck in itself, which was something that was fixed later on in a later version of the code, but this also is something that we felt a little bit of growing pains with. Okay, let's look at a little bit of detail of a particular access point and its particular access manager. Now, you'll see that there's a hub there, and I want to point out that this is not a typical instance of an installation. It just happens to be something that we inherited, and it was punctuated by this Welchia worm because things really got bottled up into this hub. So this isn't typical, but it happens to be one of the worst examples and one of the things where things suffered the most. So we're going to look at this. So from an access manager's point of view, we look down and that goes into a switch and then fans out into several access points. Looking up, we go through the hub into a router and then eventually over to our control server, which goes then back through the core to the Radius and Kerberos servers. To the left of the access manager, we see a monitor box. And in the early installation of our wireless service, we had some problems with the access managers freezing. They would lose connectivity, and someone would actually have to physically go out and power cycle the box. And that wasn't a very effective way to run our service, and it wasn't very fun either. So in conjunction with the manufacturer, we installed these monitor boxes, which had a serial cable going out to the console of the access manager so we could take a look and see what was going on there. And also it had a connection to the upstream side of the access manager as well as the downstream. So the monitor would regularly ping the downstream interface of the access manager as well as the upstream interface and the upstream router interface. And if any of those fail, then this monitor sends us a little message and lets us know. Now you can imagine that when things go bad all across campus, and you have 14 of these things screaming at you, sending email alerts. Yeah, it gets your attention. Okay, so we'll talk a little bit about the Welchia worm, and I mentioned Blaster here because I think it's relevant for a few reasons. One, it was just before, the week before our little friend Welchia, and we were actually still recovering from that. We were still cleaning up hosts left and right. There were still a number of problems with that. I mean, people still have NIMDA out there, so I guess that's no big surprise. So we're still cleaning up Welchia, which was released on the 18th of August, which is the first day of the semester. Students are coming in, they're moving into the dorms, they're starting to go to the campus cafes and everything. Blaster is also a little relevant because its primary exploit was the DCOM RPC vulnerability, which Welchia also used. So as you guys all know, Welchia finds its targets by sending out this flood of ICMP scans or flood of ICMP pings, echo requests. And the joy of this particular beastie was that it's multi-threaded and could send out up to 300 simultaneous targets. And that's a lot of pings. So let's take a look at some graphs here. This graph represents the perspective of the upstream router interface from that little diagram that I showed you there, and it represents day 2 and 3 following the release of the Welchia worm. Now, in a typical day, our normal activity, we see pretty symmetrical inbound and outbound traffic. Since this is with respect to the router interface, where it says packets in, that's into the interface. Therefore, it's packets out of the wireless network. So we'll see that just after about 12:30 or so, our first friend with the Welchia worm comes online and starts sending out his pretty little packets, and then he quickly infects somebody else, and then somebody else. It's like that old, what is it, Clairol commercial. He told 2 friends, then they told 2 friends, and they told 2 friends, and so on and so on. So that quickly saturates the bandwidth. It quickly saturates the airwaves. And as was mentioned yesterday and in several discussions, wireless networking is inherently less robust than wired networking. We're looking at 11 megabits per second shared at best, and that quickly gets saturated. But we're also looking at saturation upstream from that. Our access managers got a little overloaded. They couldn't communicate beyond that. They couldn't communicate with their control server. Authentication was hindered, so things weren't just slow for people. Oh, I can't get to, Yahoo is slow. People actually couldn't log on, so there was a limit to how many people were actually on there because of the traffic that was spewing. So the authentication was hindered, but we also had this interesting thing with the access manager and the control server. If we look back to the access manager and control server here, there's this heartbeat that goes back and forth between them. And once that's lost for whatever reason, when the access manager and control server regain connectivity, then the control server wants to send back down all of the rights that it knows, because the control server is where things are stored. The access manager just enforces those policies. So if we have all this traffic coming up, which is preventing the access manager from speaking with the control server, and now you have all of the traffic coming down as the control server is trying to restuff this information, now you're coming at it from both angles, and it's just an awful vicious circle. Okay, so what do we do about this? One of the things we want to do is we want to stop this ICMP flood, and luckily it was rather unique. The echo request that was the signature of Welchia was very, very unique and was able to be nailed down. So we're looking at an echo request, it's 92 bytes, and the payload was unique and consistent. So the underlying operating system in our wireless network, or the wireless service, the devices are all based on FreeBSD. So we can use the packet filter that comes with that, and we just put in some TCP dump rules, and we match this. Okay, it's an echo request, it's got this payload, it's this long, and cross our fingers, push the button, and hope for the best. And if we look back to the graph here, you can see just shortly before 4 p.m. is when we implemented this, and the traffic fell off. Now, that sounds all great and good, and the traffic fell off, and we regained control of our upstream, but basically we just put in earplugs, because now all of these machines are still screaming, and we can't hear them, but they're still occupying all of the bandwidth. So what are we going to do about that? Well, we're going to turn to our logs. We had this idea that when people log in, when people authenticate, if they're not already authenticated, we send them off to this login page, and from there they're allowed to see a few different things that are predetermined. They're allowed to see information pages. But why can't we make another group and send them off to something else? We can send them off to an information page, something that says, hey, your host is blocked. You need to take care of this. You need to contact our system and network security group and apply these fixes. So what I did is we made this page with all this information, went through the logs, found all of those people that had been sending out all the Welchia scans, and that was fairly easy. Look for people that are sending hundreds and thousands of ping requests, and then pull out their MAC addresses, put them into a separate group, and here you go. Now you have these people that are sent off. Now instead of connecting and doing their thing nice and slowly, checking their mail, and on the side scanning for vulnerabilities, now they're just blocked, so they're done. So that was very helpful, and now we can clean up and take care of things from both sides. Now looking back, we implemented this the packet filter, and we're dropping all of those ICMPs, but now that they're dropped, they're not logged. So we've only captured all of those people and have been able to alert those people that were active at the time. We don't know what's going on since then. I've had this idea that we can turn off the filter and then quickly watch the logs grow, and then turn it off and then go back and filter through and then alert all those people, but maybe I'll do that when I've got more time on my hands. We also have our shared wireless cards. Our library lends out cards to students, faculty, and staff if people don't have them. So you have Joe Wireless comes in with his infected computer, and then he triggers our alert, then he turns that card back in, and the next person gets it, plugs it in, and all of a sudden they're blocked. So they don't know what's going on with that. So we've had to keep track of which cards those are and track things down a little differently there. We're dependent on this signature. What if Welchia was not something that could be easily discerned from regular ICMP? I know when this first started happening, some transits were considering blocking all ICMP. And we looked at that, and that just wasn't acceptable. So here we were a little lucky, and we can't really depend on signature-based things for, that's not the end-all be-all. So looking back at this as well, we were able to decide what some of our topological improvements needed to happen. Obviously, there were some bottlenecks there, and we want to bring some things closer to the core, and we want to have consistent routing throughout. And of course, upgrades. We upgraded some of the hardware. We upgraded the software in many cases throughout the entire system. Threw some more memory in there. Things are a little more robust. I think that I'm one of those eternal optimists, and everything happens for a good reason, and we can all learn something. And we did learn a great deal from this particular event. It was painful, but we learned a lot. I learned a lot, and I hope you guys learned from or enjoyed me sharing this with you as well. So So if we have time for questions.
There's actually, they say we're supposed to use the mic, but then they turn them off. And then when they turn them on, it overshoots. Anyway, we've got time for a couple of questions. I actually think that you did a reasonably good job at basically trap and capture. And it would be interesting to see other people, hear from other people who are doing wireless stuff if they are doing similar things. But
Tony Rawle, IBM. It seemed like with your isolation setup there that there still would be overloading the wireless network. True or not?
In what sense?
They're still
the
sending
worms?
traffic over the radio waves.
The airwaves are still bogged down, but the idea was that once we isolated them, started dropping their pings, and then we were able to go back and find them and alert them. Once the students, or it could be faculty or staff, log in and they see this page that blocks them from any other activity, now they have motivation. Oh, now I need to fix this. It's not just, oh yeah, I've got this virus, I'll take care of it. I can't use wireless, so I need to contact these people and take care of my machine.
Now, I would think you'd also be affected by wired infected machines. Did you implement the same thing for the wired guys?
We have not done that because it wasn't as easy to do that on the wired side. And to be quite honest, one thing I didn't mention is that we saw a lot of Welchia flowing around on the wired side as well, but it wasn't really hurting us. It wasn't affecting us. We could see it, but we had to go look for it. Here, in this case, because of the monitors and because of the denial of service and the limited bandwidth, it was screaming in our face that we needed to take care of this. It was basically an unusable service as opposed to something that, ooh, yeah, there's a little noise on the network.
Okay, we have a pretty good wireless network too, and also wired. And our technique was with intrusion detection, find the infected guys right away, and just knock them off the network. We hadn't set up any isolation thing, which I think is a pretty good idea, especially for the wired guys, and not so sure about the wireless side. Thanks.
Thanks.
that's it. Thank you very much, Christopher.
Thank you.